Okay, so I was just going to do an example of a problem that helps illustrate the proper way to do moles to mass conversion and how and when you need to incorporate the use of Avogadro's number to go from counting moles of things to counting individual things. And so I thought this was a pretty good example. This is problem 3.63, and it's page 129 in the book. So that's also got the nearby problems are related and would be other good problems to try. I may have assigned some of them to you, and the even numbered ones are the ones I generally draw from. That's because the odd numbered ones all have the answers in the back of the book. So you can do some self-practice with those if this isn't quite enough for you. All right, so how many molecules of Freon 12 are in a certain mass, in this case 5.56 milligrams of the compound? And so in order to do this, we are first going to need to calculate how many moles of Freon 12 5.56 milligrams represents. And then once we know how many moles it is, we can use the constant of proportionality between moles and countable things, namely Avogadro's number, to calculate the final answer to this question. So we're going to do it in a couple of steps. The first thing we need to know is how we're going to get from a mass of a compound to the number of moles of the compound. Okay? And so if you recall, we have this equation, molar mass equals mass over moles. So everything hinges around the concept of molar mass, which we're going to get from the chemical formula of any compound. All right, so in this case, we're going to need to add up the different components of CCl2F2 to get the molar mass. I'll give you guys a second to do that on your own. Okay, so to get the molar mass, we just need to add up the atomic masses of all of the components of the formula. So we set up our laundry list: carbon, chlorine, and fluorine. We're going to have times 1, times 2, and times 2. And so we're going to take the atomic mass of carbon, 12.001 grams per mole. We're going to add it to 2 times 35.453 grams per mole for chlorine, and 2 times 18.998 grams per mole for fluorine. And of course, these atomic masses come from the periodic table. So adding that all up, you get 120.91. So there's our molar mass. And so now we can take our mass of Freon 12 and convert it into the number of moles of Freon 12 by simply rearranging this formula, right? We need to solve for moles. So we bring moles up here. Moles is going to be equal to mass divided by molecular weight. So molar mass, I sometimes use the 2-letter abbreviation MW for that. So molar mass goes on the bottom. And so our mass here is going to be 5.56 times 10 to the minus 3 grams. Notice that I accounted for the fact that it was milligrams just by changing the exponent on my power of 10 in scientific notation. Okay, and now I've got the molecular weight of 120.913 grams per mole. And if we're paying attention to our dimensional analysis, this should make us really happy. We've got grams on the top, we've got grams here. The moles is on the bottom in the denominator, which means it's going to pop up to the top. And then we're going to get our final answer. Final answer, which is 4.598 times 10 to the minus 5 moles. Okay, we're keeping a little bit of extra precision. We're going to round to the right number of sig figs at the end, of course, the way we always do. Okay, so this is our number of moles. But the problem isn't asking for number of moles, it's asking for the number of molecules. So that means we need to take the moles, and just like if you were asked for dozen, and I said it's 5 dozen eggs, how many eggs is it? You need to multiply by the number of things in a dozen in order to be able to answer that question. You'd say, oh, 5 times 12 is 60. So In this case, we need to multiply by the number of things in a mole. It's a much bigger number, but it's the same concept. So what we're going to do is we're going to multiply by Avogadro's number, which you may have memorized by now. You could certainly look it up. It's going to be equal to 5.598 times 10 to the minus 5 moles times 6.022 times 10 to the 23rd. And the units on Avogadro's number are per mole, or mole to the minus 1, or 1 over mole. The idea here is that we are going to cancel out, dimensional analysis again, we're going to cancel out our moles and the answer because there aren't any units on the number of things, right? It's just the answer should just be a number. How many molecules? And so the final answer is 2.768 times 10 to the 19th molecules of Freon-12. And if we look back at the given information, we see that we had only 3 sig figs in our mass that we were given. So that means we should round this off to 3 sig figs, leaving us with 2.77 times 10 to the 19th as our final answer. That's how many molecules of Freon we have. Okay, so just to sum up, the key ideas here were that we needed to convert our given mass into moles by using the molecular weight, which we calculated over here. So we use the molecular weight in this equation, rearranged to solve for moles. We got our answer. And then since that was given in moles, in order to get individual countable objects, we had to multiply by Avogadro's number to get our final answer.